This video will cover an introduction into indices and exponent rules. So, let's first start by understanding some of the components that I will be referring to throughout this video. So, you have the bottom number and you have the top number. Now, what does this mean? This big number at the bottom, this is called the base. Now, this top number, this is the exponent or index, whatever you want to call it. Now, let's dive deep into the rules. So, let's say you have x to the third power times x to the seventh power. What would this equal? Well, we can take the exponents, just simply add them together. So, this would look like x to the 7 plus 3, which is equal to x to the 10th. Notice that x to the third plus x to the 7th, this does not equal x to the 10th. Alright, now let's understand why this works. So, we have x to the third. Let's write that out. X times x times x. This is to the third. Now we multiply it again by x to the 7th. So x, 2, 3, 4, 5, 6, 7. This is actually equal to x to the 10 because x is just multiplying itself 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why this rule works. Now, what happens if you have x to the third power over x to the second power? Well, let's expand this. This would just equal x times x times x all over x times x. Now, this is easier to look at, so this is easier to simplify. So we just cross this out twice, right? So the answer would be x. Now a shortcut to do this would just to be taking the top exponent in the numerator and subtracting the exponent in the denominator. So it would just be 3 minus 2. And let's see another example. So what would happen if you have x to the third power to the 7th power? Well, we can just multiply 7 and 3 and we get 21, right? So x to the 21st. And to why this works, we can just imagine x times x times x. We multiply this 7 times, and if you do the 7 times, you'll get 21 x's. So that's why it equals x to the 21st. Now, this is a very interesting rule. Anything to the 0th power is equal to 1. So it doesn't matter, like pi to the power of 0 is equal to 1, x plus 1 million. That to the 0th power is equal to 1. Anything to the power 0 equals to 1. Now, what happens if you have this situation? Well, this is the same as multiplying itself twice, right? So we can actually distribute this too. And this would just equal 7 squared over 3 squared. And we can do this with variables as well. So y over x. Let's do x squared actually, to the third power. Well, let's just distribute this. And now does this look familiar? This situation? Well, we can just multiply the 3 by the 2. So this would just equal y to the third over x to the 6th. Because we distributed the 3 to the y, and then we multiplied these two together to get 6. So it'd be y to the third power over x to the 6th power. Now, for a rule regarding negative exponents, you will have a situation where just any number, m can be any number, this would be the inverse. So it would be 1 over a to the m. So we take away the minus sign and we turn it positive, and then we put it all under 1. So what this can look like is 8 to the negative third. This would just equal 1 over 8 to the third. Same thing here. 1 over 7 to the fourth. Let's move on to the final rule. What happens if you have a fractional exponent? Well, this would equal to the square root of x. So we have the formula a to the power of x over y. This is equal to y, the yth root of a to the x power. So we can see here by looking at the components, y is equal to 2 in this situation. So the second or square root, and then this one is equal to the x. Oh, sorry. So that is just 1. So this is just equal to the square root of x. In another situation, let's say you have x to the 5/2. Well, let's identify the y. Y is 2 here, so it'd still be the square root. And then you have x2, let's identify x, that is 5. So it would be the square root of x to the 5th power. And that is most of the rules that we'll be covering today. And these rules you will encounter a lot throughout precalculus and even after precalculus while you're doing your calculus courses. So I hope this video was helpful, and I'll see you in the next video.